Hey, what's up everybody? Welcome to the problem number 2 about parabolic throw or projectile shot. Well, in this case, for example, I have the initial velocity that is 80 meters per second and the maximum height that is 250 meters. So imagine that you are going to throw something, yes? And this is the drawing. And you are going to throw it at 80 meters per second. Now this one over here is the resultant vector. Okay, remember that every part of the problem, every object at any given time is going to have the resultant vector, something like this. This is the initial velocity, and every vector has two rectangular components. This is the initial velocity in x, and this is the initial velocity in y. Okay, so the only data that I have is the magnitude, so that means that I don't have the angle, this angle over here. This is the initial angle. Okay, and for example, imagine that you throw something. It could be a stone or anything, a ball, something like that, and the maximum height that the object reaches is 250 meters. So this point over here is the maximum height. Okay, maximum height. This will be maximum height. Okay, or if you want to say that at this point the object reaches the maximum height. So there are questions. Okay, so the first question is, what is the initial angle? Okay, what is the total time? The total time, remember, this is, I can say that this is time 1 and this is time 2. Okay, something like this. And this is time 2 and this is total time. Okay, time 2 is the time that takes the object to reach the maximum height, and time 2 is the time that the object takes to reach from maximum height to reach the initial height. Okay, and total time, well, that's the time that the object takes to reach the final position. This is initial position, and this point over here is final position. Okay, now and I need to find the final position or total distance or range. I mean, these three letters are the same. That's how you're gonna find them, or maybe you're gonna find them in any problem. Okay, so I'm going to write the equations that I'm going to use. If you don't know where those equations come from, well, I recommend you to watch the first video about parabolic throw that is on my channel. I'm gonna place a car over here that is gonna take you over there. Okay, so for example, in order to, well, what can I do? Well, I'm going to focus on this one, maximum height. I got an equation about for maximum height, and that equation comes from the topic of free fall. Okay, I got a video that talks about free fall that is going to be over here if you want to watch it. Okay, so that equation, I'm gonna write it over here, maximum height, max, that says minus acceleration in y, that multiplies the time, in this case what time? Okay, the time that takes to reach the maximum height. So it could be time 1 or time 2 or the total time. No, it's not gonna be the total time. So it's gonna be time 2, because remember that we got this equation from free fall. Now, if you remember, we're going to divide the problem in two segments. This is the segment number 1 and this is the segment number 2. Now, free fall is on the segment number 2, because in the segment number 2 the object goes down. In the segment number 1 the object goes up. So I told you in the previous video that this could be treated as vertical throw. Oops. And the segment number 2 can be treated as free fall. Okay, free fall. So that's why in free fall I'm going to use time 2. That's why I'm going to write time 2. It's because in free fall now I'm on the segment number 2, but it could be time 1 if you wish, because time 1 equals times 2, okay, over 2. So with another color I can say, oh, well, I got maximum height, I got the acceleration in y, that is going to be the gravity, but I don't have time 2, okay. So I can write the other equation, the equation for time from free fall. So time 2, so that means the time that takes the object to go from the maximum height to the original height, okay. So it's going to be minus 2 times the maximum height. Now if you remember the maximum height from free fall, the letter is initial position of the segment 2, because in the segment 2, this segment over here, the motion begins over here, okay. This is where the motion begins, and this is the initial position of the segment number 2, that is maximum height. But that information, all that information comes from the video of free fall that I recommend you to watch, okay. Minus 2 times the initial position or maximum height over the acceleration of the gravity, sorry, of acceleration in y, that in this case is the acceleration of gravity, okay. So everything is going to be inside of the square root. Sorry, I forgot here, because in this equation I got square root. Okay, so let's do in the calculator. Time 2, okay, equals minus 2 times a square root fraction minus 2 times 250 meters over the value of the acceleration in y, that is the gravity, that is minus 9.8 meters per second, and that is time 2, okay. I'm gonna save this value in my memory of the calculator, okay. So time 2 equals how much? 7.14 28 seconds, okay. And I just saved this value in my memory A of my calculator, okay. But this is time 2. It's not total time, but you just need to remember that total time equals 2 times time 2, or 2 times time 1, but time 1 equals times 2, okay. So I hope there is no problem with that. So let's get the calculator. So I'm just gonna do 2 times A equals, and this is going to be the total time, and I'm gonna save this value in my memory B of my calculator, okay. So how much is that? Total time equals 14.2857 seconds, okay, and this value is saved in the memory B. Okay, so I'm gonna circle this in the calculator. Sorry, I'm gonna circle this because this is the letter B. Okay, that's letter B. So I got this object is going to be thrown at 80 meters per second, so it's gonna take around 14 meters to reach here, the maximum height, okay. Now what can I do? I need to find the total distance. In order to find the total distance, well, there is a formula that says something like this: total distance equals the velocity in x that multiplies the total time. So I don't have this one, I don't have this one, and the only letter that I have is the total time, so I cannot use that equation, okay. So what can I do? Well, if you remember from the previous video, okay, this is the segment 1, okay. The velocity here at the maximum height just as we saw in vertical throw, the velocity in y is 0 meters per second. Okay, so there is an equation that says something like this. Acceleration in y equals final velocity in y minus initial velocity in y over time. And also I used this equation in the previous video. So if I'm talking about the first segment, so this over here is the initial velocity and this over here is going to be the final velocity. So the final velocity is going to be 0. Okay, I'm going to cancel it. So acceleration in y equals negative initial velocity in y over time. But what time? Of course, it's going to be the time 1, the time that takes the object to reach the maximum height. So this is going to be time 1, okay? So from that equation, I'm going to isolate. Okay, well, let's see what I have before I isolate. Acceleration in y, I got acceleration in y, I got time 1, but I don't have initial velocity in y. So I can find that one. So if I find it, well, I'm just going to write it again. I'm gonna do this. Initial velocity in y equals minus acceleration in y minus acceleration in y that multiplies time 1. And remember that time 1 equals time 2. Okay, but I don't want the initial velocity in y. What I want is the angle, okay, the initial angle. And remember that initial velocity in y equals initial velocity that multiplies the sine of the initial angle, and this is going to be equals to minus acceleration in y that multiplies time 1. Okay, so from this equation, I'm going to isolate sine of the angle, initial angle. So sine of initial angle equals minus acceleration in y that multiplies the time 1 over initial velocity. So finally, the initial angle equals sine inverse of minus acceleration in y that multiplies time 1 over initial velocity. Okay, so let's do it in the calculator over here. Okay, so it's going to be shift sine fraction negative the acceleration, that the acceleration is also negative, times time 1, and time 1 equals times 2, and that value I got it saved in memory A, over initial velocity. How much is initial velocity? Is 80 meters per second. Okay, so, and I'm gonna close parentheses. So how much is that? Boom. Okay, that is the initial angle. Just before I continue, remember that the initial angle, in order to find the angle, we are finding the total angle, the angle that is measured from 0 degrees. And this is something we saw in the first videos of our playlist. Okay, so in order to find the total angle, we need to identify which quadrant we are working with. If this is a Cartesian plane, well, this is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. So in the first quadrant, there is no problem because the angle that I just find is the total angle. So we don't need to do something else like adding 180 or subtracting 180 or something like that. Okay, so I'm just gonna write the answer over here. Initial angle equals 61.0449 degrees, and that's letter A. Okay, this is letter A. I'm gonna circle with red, and I'm gonna save this memory in AB. Okay, I guess the other letter is gonna be ABC. Okay, so let's save it in C. Shift STOC. Okay, now Now I need to find the only thing that I haven't found is total distance. Okay, so total distance, I'm gonna use this equation over here. So I'm just going to continue writing it. So total distance equals bx. Remember that there is an equation that says that bx equals initial velocity that multiplies the cosine of the initial angle. Okay, and that multiplies total time. Okay, so I already got that information because I already got the initial angle. So it's going to be initial velocity. How much is initial velocity? Well, I guess is 80 meters per second. So 80 meters per second times cosine of the initial angle. Oops, that is saving C. I need to do it because I don't remember if I just saved it. Yes, okay, so again, 80 times cosine of the initial angle, that is the letter C, um, that multiplies the total time. Okay, total time is in letter B. Okay, alpha B. How much is that? That is the total distance, 553.2833 meters. So I'm gonna circle this. I don't need to save it in my memory because that is the last answer that I needed to find. So this is letter C. So that is the problem number 2. I hope I made myself clear. I hope you understood. If not, well, I recommend you to watch this video again and try to do the procedures. And in the next video, we're going to see the problem number 3, and that might be the last problem, unless, I mean, I don't know, you comment in the comment section that you need to see. You want to watch more problems about this. Okay, so take care, guys. Bye bye.